multiple quantum bits. And this, I'm just thinking if we will be able to cover by then I will be doing giving this quantum adders and universal quantum gate. But it totally depends if I'm able to complete the topics. I'm not going to overburden you with this course because this is a new one. So these two depends. I will take the class today, tomorrow, Saturday, then Monday, Tuesday, Wednesday. Because I suppose from Friday you are having your midterms.
Actually, many
Okay.
students have gone. Actually,
So
ma'am,
with it,
many students have gone for
yes.
inter triple IT. Hello.
Okay.
Yes, ma'am. So, please do
Now they
not
have gone. Now what you want from
give
me?
much
Yes, yes, I
syllabus.
am listening. Mhm. Okay,
Yes.
that's mm, okay. So that I told you, no. Whatever I will be covering in this till Wednesday, only that much I am going to give you. I will be going a very slow pace because the subject is new. If the topics are less covered are less than this, I will be giving you less than this.
But they will not be
Okay?
able to. I
So
think what
don't
they will.
and my exam paper or something will be just whatever we have covered in the exam. Some mathematical. No, just no. I am getting your problem. Now you tell me the solution. Problem I have understood. They have not they will not be able to study. They will not be understood. What is the solution?
We can have, ma'am, three classes, ma'am.
I'm just covering the basic. Yeah. Just three classes. Okay, so see, I will be giving you till these topics. Multiple quantum week I can have after midterm, but this way I will be covering. I cannot make smaller than this.
Okay, ma'am.
Three classes means till Saturday.
Yes, ma'am.
Okay, let's start. First of all, let's start the course. Okay, now first of all, understand what is a quantum bit. So normally we define quantum bit almost similar. Q bit is similar to a classical bit with some difference also. So I will make you understand with the very interesting thing. Quantum bit, if simply you say you are having a, suppose you are having a game which is something having two endpoints marked as plus and minus, and you have 52 deck of cards. Now that deck of card and you have one coin. This normally I denote as one, and this I normally I denote as one. Now the first, I throw a dice and I'm in a condition of one or zero. This is my initial position either in this point or in this point. Now I'm having a deck of card 52, because normally we resemble by 52 deck of card. I'm having a deck of card. But now these deck of cards, instead of having this numbering like 1, 2, 3, JQK, these are having some mappings. What are these mapping? Like it's showing the movement. Go to saying the point, go in this direction. Or somewhat point in this. Somewhat in this direction. In this direction. In this direction. In this direction. That means I'm having a coin and the card is saying how the coin has to be moved. And the deck is designed, the direction it says it move into this. The objective is if you are starting with one, you have to reach in who reach in the least number of moves is the winner. Got it? So have you got an idea? Now this concept or this game is somewhat similar to your quantum electron. What is that? Now simply the electron may be in any of the state, and this is, it can be Now, when I say electron, a quantum or electron is in a superposition, what does it say? It is in between one of zero. It is anywhere in there. The state, if I say it is not exactly 1, it is not exactly 0, it is somewhere in middle. And as these cards are governing where to move, similarly with the coding and difference gates, we are going to control or govern where the electron is. And that is why we say in quantum the electron, or the simply it's a superposition. The qubit or quantum bit is a superposition of 1 and 0. So if I define a quantum bit, it is simply we say it is superposition of 0 and 1. And I suppose you remember in the last class, these are nothing, this is just a vector notation defining where. Now you understood what do you mean by superposition and what is the ultimate objective. See, the moment you enter in 0 or 1, game ends, game ends. Till you are in anywhere on the board, you are in a superposition, in a probable state. That is why we say a quantum state is defined as that. That means alpha and beta are called as probability amplitudes such that this condition is satisfied. Got a small idea of what does it mean? Now to make you understand more
Excuse me, ma'am. What is alpha and beta, ma'am? Can you explain again?
correctly, the alpha and beta
Excuse me,
are
ma'am.
called as
We are not able to
probability
listen you.
amplitude. Sorry, abhi just we will be doing more detail. Probability, that means they define the probability that how much how much the chances is to go to the state 0 or how much is the chances to get to state 1. Not able to listen me? Okay. Uh, Let me check the network. Network is perfect. I think the network is slow. That's the reason. Hmm. Network is working, but it's, I suppose I think it's slow. Okay. Just I started. What is missed? Just tell me. I will just repeat it. I was just telling you how to understand this quantum bits. So quantum, I'm just giving you from the basic idea because the more you understand the subject, it will be easy for you. So this subject or the objective is to subject is to make you move from classical computing to quantum. In classical, you deal with bit 0 and 1. Quantum, as I told you in this, it is not in the exact 0 and 1. In classical, I was like in 0 state and 1 state. In the last class I told it is a superposition. Now, what do you mean by superposition? To make you understand, I give you an example of a board game. In a board game, we have two places like 1, 0. Got it? Now, I start with any of the position 1, 0. I start playing and this thing. Now I have 52 deck of card. I pick a card. I just got it out. Okay, move this, move this. It can be any deck. Move left, move by this angle, move by that angle. So where is my that dice or where is that my whatever thing I am choosing it to place it? So, suppose I take it as a dice only or a coin. Suppose I am placing it anywhere. Now till I win the game, till I am in a situation of 0, if I started in 1, I reach to 0, or if I started in 0, I will be anywhere on the board. Similar is like quantum. When you talk about quantum bit is not an exact value. It is a simple probability that the electron will be in this position, electron will be having this magnetic moment, electron will be so we say that this is a superposition. Got it? So quantum bit we define it as psi, where it is alpha 0 beta 0. What does it say? It say, if you remember, this is a vector notation. Got it? Got it? 0, 1. What normally in this I'm representing these two as 0 and 1. What is it? Will it always be 0, 1, or it will be different? We call them as bases, which I will be discussing today's class. But if I'm dealing with only like this game choice, I have two choices of 0 and 1. So my qubit state is combination of this. That means alpha and closer to 0 or beta and closer to 1. That means this position is this with this probability in the 0 and 1. So this is how we define a quantum bit. And the condition for this is the sum of alpha plus beta should not be 1. No, their square norm should be 1. Here alpha and beta are complex numbers. And why complex numbers? That we will learn also in today's class. Just wait a minute, there is one phone call. Hello? हाँ जी, तो दे दीजिए भैया. आप भैया. Sorry बच्चों. Okay. Hmm. Why are these complex numbers? Why? That will be just I will be discussing. But till now you understand these alpha beta are complex number, so their sum should not be equal to 1. Normally the condition is the sum of all the probability should be 1. No, yes it should be, but in this that is how is called as alpha square plus beta square is equal to 1. Why this is chosen, that also has a logic that I will be explaining you in today's class only. Now understand, this was just an example I have given you. Now if you remember, when we talk about the electronic configuration that I told you in the last class also, we says the electron are revolving in a shell, nucleus and covering. So what is that path? So if you remember, this is your nucleus and these are the shells. Are these shells circle? No, these shells are not circle. These shells are sphere. And when we talk about this quantum bit and electron position, for donating the position, we use a sphere, we call it as Bloch sphere. This sphere has radius 1. Now, how we represent? Just I will try to make it in the 3D, it's x-axis and this as x-axis. So you can relate it. These are the three axes. Okay. Now, when I say, suppose a point is here, this is a point. Now just understands this, if this my z-axis equator, just understand this point is at an equal distance if I call this as 0 and if I call this as 1. So if I call it a, just look at this is at equal distance, because don't look at the circumference wise, just look at the 3D phase. It is from the equal distance from 0 and it is equal distance from 1. So we say the state of this electron at this position is superposition of 1 and 0 and it is equidistance. So we denote is like this. So now when I talk about this probability, just have a look. Alpha square is 1 upon 2, beta square is 1 upon 2, and just see they are satisfying the property. So if I tell the dimension of this point, it will be 1, 0, 0. Similarly, if the electron is on the negative side, or if I say the coordinate of the electron is minus 100, we will be representing it as 1 upon root 2, 1 0 minus 1. Okay. Now this was the condition when it was on x-axis plus and minus side. Now let's take the electron. Suppose the electron is on this axis. See, when the electron is on this condition, that means it is on this side, simply we have at 0 at 100% probability. So in this case, you will be denoting the electron as in this configuration. Or simply if I write it like this. Now suppose the electron is on this z-axis itself. So in this condition, when the coordinate is 0, 0, 1, your it is this. It's not in a superposition, it is exact this. It has collapsed or it is in one state. Now simply when the electron is in this one, 0, 0, minus 1, we call it as it is in this configuration. Now let's talk about this y. Suppose the electron is on exact y axis. So the coordinate of this y axis is in here. It is represented as क्या problem है यार इसका भी? Hello. 6680 6680 6680. Sorry. Okay, now suppose the electron is on y-axis. Now how will I denote is in this thing? Here we will be using the phase as iota. So the representation is plus iota 1. And similarly, when the coordinate is in that case, you will be writing as why this is coming. Now it's clear. Okay, let me summarize it. So as I told you, when we talk about electron, normally the electron is like a sphere. Okay, so let us first of all talk. As I told you on this game bit, it can be any of the condition. So an electron or the information that you have to represent can be in any of the position. To understand in a similar manner, let's first of all work on when the electron is on the axis. So I'm representing, I'm just talking about if the electron is on z axis. So z are like the board condition of 0 and 1, winning and losing condition. Now and the thing is, when electron is on the north pole, simply I said the quantum qubit is 0 with one probability. 100% is in that state, it's not in a superposition, it is on the north pole, it is on the 0 point. Okay, now similar when the electron is on the x axis, so it is halfway from 0 and halfway from 1. So I've represented it as 1 upon root 2 this. Now why 1 upon root 2? Just look at this and why, how we design, how we got 1 upon root 2. I will be just explaining it till now understand that it is given like this. Why? It is also having an explanation. Nothing you have to remember. Similarly, when it is on the y-axis, now again it will be 1 upon root 2 minus 1 upon root 2. And from this only you will be understanding why we say that alpha, beta are complex numbers. Because here you are representing the angle difference that they are making from the z-axis. And if you remember, the complex numbers are capable of representing the coordinate in of any point in a coordinate system like our theta system also. I don't remember what we call them, or in a normally Cartesian number wise system also. So I suppose all of you are guided. Let's summarize it, how we write it. So simply, when the quantum bit is on x-axis, positive side, we represent it like this. When the electron is on the x-axis, and this qubit is similarly when it was on the x-axis, when it is on the y-axis, we represent it as iota. Today network is creating a problem. I note it, just understand it. And this is my sphere. Okay. So this one, this has 0, minus. I hope you have understood what does these represent, these simple qubits. Now simply if I ask you some question, let us just try it. So if in a short I define a qubit can be any point on the Bloch sphere. Okay. Now question is, let me ask you some questions. Where is exactly this? What is your answer? If I write the qubit is this, then where is the electron exactly? I suppose with this you can give the answer, because see, when I'm saying it is 0, if I define 0 as a north pole, it is exactly in the north pole. And simply I say when the qubit is 1, where is the electron? It is exactly in the south pole. Okay. Now the question is, where is qubit on this? It is half on 0 and half on 1. So simply where it is, definitely it is on this x-axis, or we can say simply it is on the equator. Okay. So this is simply to understand what does this information say.
Ma'am,
Huh?
for the same question, can it be on the y-axis?
Yes, yes, I will. So simply if you say it on mm, halfway on this thing, normally that you can define it halfway, that's why I said it, if I'm defining it on the equator, you can simply say it, yes, you can define it on the x-axis or on the y-axis, because only the iota or the value changes. Yes, it can be on x-axis, or also it can be on y-axis also. Yes. Acha, now one more thing, I will give you one more question to this, is more interesting. Where is qubit? Suppose I'm saying that your 0 is north pole, this is your 0. Suppose this is your north pole and this is your south pole. Now the question is, where is qubit is more 0 means it is more closer to this than this, the 0 than this. So what will you say to it is? It is more closer to 0, that means probability towards 0 is more. So we can say it is more in the northern hemisphere, more inclined toward, because at north pole is of 0, so it will be anywhere towards the north hemisphere. And when I say the probability of 1 is more, then we can say the qubit or the electron probability is more toward the southern hemisphere. Now you understand the concept of probability? Clear?
Yes, ma'am.
Yes, ma'am.
Hmm. See, this subject is a tough one and you will not find anything on the net. So understand, I'm making this subject very easy and very interesting for you. So I'm just sticking in very small. That's why I've made some questions and framed some question also for you. So you can understand that these sort of questions only I'm going to give you an exam. You can easily do them also. Now, as I told you, this alpha and beta are complex number. Why complex number? Let's have a brief idea of. So I'm just giving you quick review of the complex number and their relationship with the quantum. I will just quickly review it because you all are aware. We represent a complex number by x plus iota y. X is a real part, y is a imaginary part. So this normally we call it as Cartesian form. There is one more form, we call it as polar form of representing this. And complex number has very much importance in the polar form. Now, how is this polar form? Let's have a look. We talk it as a real axis and this as the imaginary or your y-axis. And this is your point. This is definitely your y. So can I say that x is equal to r cos theta and y is equal to r sin theta? Square plus y square is equal to r square. So this I might be forgetting, you might remember. A Euler formula says E iota theta is equal to cos. This is I'm assuming. I have no idea. I've forgotten maths. So user has given this formula with this assumption. So if I take r iota theta, r iota sin theta is a complex number in the polar coordinate system. So suppose a coordinate is written to you as x plus iota 3. Now you have to find out, now first of all I have to find the angle. So for the
Ma'am, your
angle,
voice is breaking so much, ma'am.
what is tan theta? This is r sin theta upon r cos theta. My voice. Till what point you have understood? I will repeat. I think from where you have not understood,
Yes,
I will
ma'am.
repeat it. So I've just given you an idea, started with the idea of complex numbers. We denote the complex number by x plus iota y. So if you represent, we can also write it in the polar form like z is equal to x is equal to r iota theta. Why? Because a Euler formula is this: E iota theta is cos theta plus iota sin theta. Now understand this: when you denote x complex number in a Cartesian plane, this is the representation. On x it is x, on y it is the distance y. So with this you can relate it x plus y. And when this this E iota theta is multiplied by R, you get R cos theta plus R iota sin theta, which is equal to X plus iota V. So this gives an information that if a complex number is X plus iota V, the polar form of this can be this. Now, if I have to represent it in a polar form, how will I represent? So tan theta is y upon x. So in this case, your tan theta is or we can say pi by 6. And now what is your r? Your r is x square plus y square root. So it is 1 plus 3 root, which is 2. So the polar representation of this, simply it is 2 e to the power iota pi by 3. Is it clear? Root 2. Okay. What? हेलो. हाँ बोलो. हाँ हाँ. हाँ student, are you able to get the question? What will be the polar coordinate of this? It's a very simple thing. So when I talk about tan theta will be y upon x. So it is root 2 divided by root 2, which is 1. So simply your theta is 45 degree, and which is equal to pi by 4. So and if I define your r, so it will be 2 plus 2, which is again 2. So it will be 2 e iota pi by 4. Now, if possible, just try for this number. What will be the form of 1 plus 2 iota? Okay. Now, simple. Complex conjugate. What is complex conjugate? If your z is x plus iota y, the complex conjugate of this is x
मैम मैं आपकी वॉइस
minus
बहुत ज्यादा लैग कर रही है.
iota y. If I denote it is in the form of polar form r theta, then the complex conjugate is r is equal to iota minus theta. So these are some terminologies that we'll be using. So one is this complex conjugate, the other is norm. Is my voice again also breaking or now it's coming clear? Okay, I will just cover this complex number because this is basic. क्या करूं? चलो. What's the solution? I think it's a LAN issue that I'm able to see this in the system also. Just showing the network is perfect. I will just try to complete this basic part. If nothing, if you're not able to understand, then I will repeat it. But I'm just covering it the basic one first. Norm of or simply if I say it is z into its conjugate. This we can say from x plus iota y into x minus iota y. It is x square plus y square, which is equal to z square. In the polar form, iota theta into r, iota minus theta, which is also equal to r square. Okay. So the reason why we are discussing this, now you have got an idea. Then see complex number, with the help of complex number, you are able to represent any number on the whole because it will be having any of the angle. When I talk about 3 degrees, simply in the sphere we have angle 360. So it is very easy with this theta notation. You can simply say the length from the origin, that is in a vector form, and this theta will be measuring what is the angle from the origin with the axis it is making. Is it clear? That is the reason we always say that the coefficient of a qubit are complex numbers, because somewhat you will be getting the exact value when you are going to currently though I have just told you about xy axis. We have done the complex number only with xy axis, but now it is a sphere. That means z dimension will also come. So how the z dimension measurement will vary, and that will actually define your quantum bit. Now you are giving me thing that you are not able to listen me properly, and now I will be taking the part that is measurement in z axis. So you suggest me what should do I do? I'm not. अभी भी unclear है बच्चों वॉइस? Student, my voice is not clear yet.
Yes, ma'am.
It's not clear.
Yes, ma'am, it's not clear.
Okay. I have no option. Maybe this is a network issue. Please, Reek must be breaking. Okay, I will just do one thing. There's a lot of you are suggesting. I will re-log in and reconnect it. Better is that.